All right, so this is for Chapter 14.3, Section 3, Day 6 notes on probability. Now, before we start this, just realize that we are starting to kind of shift gears here. Although we're still going to need to find the number of options for an event or the number of combinations in order to help us find probability, we're really shifting towards this focus on actually finding the probability, okay, and also using the addition rule to help us find the probability. So probability in general is something we should all know. It's just the likelihood an event will occur. Likelihood an event will occur. The basic calculations you should have seen many times before. The idea is that the probability of the event, so I'll just put E. If it were tails, we'd say the probability of getting a tails when flipping a coin is equal to the number of events that you want over the total number possible. So when we look at this, this is the number of times the event you want to occurs. The number of times the event you want occurs, divided by the number of total items possible. Sorry about that. We'll zoom out a minute. Number of total items possible. Okay. Sometimes you'll need to make a list, and this is going to be actually happening a lot today. So sometimes you'll need to make a list of all possible items. I should say items or events, right? All possible items / events before calculating probability. Sometimes you can calculate the total possible items and items that fill the space before calculating probability. So sometimes you'll have to calculate the total possible items and items that fill requirement first. So before you find probability. And that's going to be a big deal today. Looking at them and saying, hey, what are the number of events that would make what we want to happen happen? What are the total number of events? So number one, I kind of feel like is more straightforward. So when we read through it, it says the probability a bag contains 5 Twix, 10 Snickers, 8 Twizzlers, and 12 Airheads. All right? So this should be a pretty straightforward probability question from like Algebra 1. So the idea is I want a Snickers. So the total number of ways I can get what I want is 10 out of how many total? Well, there are 5 plus 10 plus 8 plus 12 different events that could happen, and that totals to 30. So it would be 10 over 30, which we reduce to 1/3. And yes, please leave your probability in fraction form. Okay? So the second probability says I want Airheads or a Snickers. So that means Snickers are something that I want. Airheads are something that I want. So I want Snickers, which is 10 options to get what I want, and Airheads, which are 12 options to get what I want, out of 30 options total. So then that would give me 22 out of 30, which reduces to 11/15. Now the last one is one that kind of tricks people up because it says probability of not Twix. So think about what you actually want if you do not want Twix. And I want you to go ahead and try this one on your own. But really think about what is it that I want if I do not want Twix, okay? And go ahead and try to figure that one out on your own. So let's look at, you can pause the video, try it, and then go back to the video, or just do this at the end. So number 2, a set of 3 coins, so we're starting out with 3 coins, are flipped in the air and their results are recorded. We want to know what's the probability of getting 2 heads. Well, I don't really know because I don't know what my options are. So for this one, we need to make list of possible events. In other words, we can start this out with if I roll a heads and a heads and a head, that is one of them. And then I gradually start changing things. So I keep the first 2 heads and then I change the next one to tails. Well, then I would say, okay, how about if this one still stays heads, but this one changes to tails and that one stays a head? And what if it were heads and then these both were tails? So far, heads with 2 heads, heads with 1 head and 1 tail, heads with tails first and then heads with 2 tails. Now we can start out with the tails one, right? So tails, tails, tails. The first 2 are tails and the third one is a head. The outer ones are tails and the middle one's a head. Or both of the end ones are heads. So there are 1, 2, 3, 4, 5, 6, 7, 8 different options. And that should make sense, right? Because really, we could think about this as we have 3 different things. We're flipping 3 different coins. We could have either heads or tails, heads or tails, heads or tails. Multiply them all together. Means that there are 8 possible events. So that tells me out of all of these, the denominator will always be 8. Now, I want to know which ones of these have 2 heads. So I want to have 2 heads. So when I look at this one has 3 heads. That doesn't count. This one has 2 heads. This one has 2 heads. That one has 1 head, no heads, 1 head, 1 head, 2 heads. So we have 1, 2, 3 ways to get 2 heads out of 8 total. Now I want you to use this list to help you find... Oops, sorry guys, you couldn't see that. I want you to use that list to help you find B and C on your own. All right, and the last one for this page, number 3, right? If a pair of dice is tossed, then what is the probability of getting 24? So we have a pair of dice, right? We could literally list out every single option, like 1, 1, 1, 2, 1, 3, right? 1, 4, 1, 5, 1, 6. And then we're going to have to do that for every single one. But again, if we're tossing a pair means 2, right? So I have 1, 2. And how many options do we have for the first die? Well, 1, 2, 3, 4, 5, 6 means 6 because there's 6 different ones on each side. And then 1, 2, 3, 4, 5, 6 is 6 for this one. Multiply it together, and there are 36 possibilities. So these are my 36 different events that can happen. And I can list out all of them if that helps me with this, but sometimes you don't need to. So for example, number 1 asks that we get a sum of 24. Well, sum means to add. Well, even if I add the highest number, 6 plus 6 is still 12. There's no way to add 2 of those numbers together, 1 through 6, and to get 12. So it's 0 out of 36, which means my probability is 0, because highest sum is 12, because it's 6 plus 6, which is 12. Okay? So now for this next one, it says getting a 5 on the first toss. Well, let's just list all the ways we can get 5 on the first toss. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. So I have 1, 2, 3, 4, 5, 6 ways to get what I want on the first toss out of 36 total, which reduces to 1 out of 6. Okay. Next one asks, how do I get a sum of 12? So I need things that add together to give me 12. So can I do 1 plus anything and get 12? Well, 1 plus 11, but 11 isn't a number on the die. How about 2? Does 2 plus anything give me 12? Well, 2 plus 10, but 10 is not a number on the die. 3 plus 7, but 7 is not a number on the die. 4 plus 6, or sorry, I have to add to 12. So 4 plus 8, but 8's not a number on the die. 5 plus 7, but that's not a number on the die. So I'm adding to 12. So 1 and 11, 2 and 10, 3 and 9, 4 and 8, 5 and 7, but 6 and 6. So 6, 6 is the only one that I could get to give me 12. So that means my probability is 1 out of 36, and that can't reduce, so that's my answer. So now I want you to try D and E on your own. If you need to, list out every possibility to make that easier on yourself. Okay? And we're going to pause and go to the next video for the back side.